Now let's suppose that we want the output layer to have nodes for both the values. Okay, acceptance equal to like and acceptance equal to dislike. Okay, if you want for both of them, okay, how do you set this up? So we need to have separate columns for each of the possible values of the target. So we have to create, so to create two output nodes, one for each value, we have to create a new column. Okay, so let's call this, say, in tiny.df, we'll create a new column and we'll call that like. Okay, so see, tiny.df acceptance. Okay, it's a comparison, two equal signs, and then we say like. So now this new column will be populated with true whenever the value is like and false whenever the value is not like. So true will be like 1, false will be like 0. Okay? And we create one more column. We'll call that dislike, and we will check whether the value in acceptance column is dislike. So when you run these two lines of code, your tiny.df will get two additional columns. One called like, and that will have true or false, okay, with respect to the acceptance, and the second column called dislike. Okay, so now you see wherever acceptance is like, you have a true there. Wherever acceptance is dislike, you have a true in this column. So we need to use these two columns. Okay, so we use these two columns to train. Okay, let's save this in NN2. So neural net. Okay, now we need to do set seed here. The reason why we need set seed is the initial weights are randomly set and the learning rate is randomly selected. So whenever there is a randomness involved, okay, for reproducibility, you need to use set seed. So neural net, so now you have two columns. So your target side you'll have to specify the two columns representing the two nodes. And then you specify what the predictors are. So here we want to use for predictors salt plus fat, okay, and data equal to tiny.df, say hidden equal to 3, and say linear output equal to false. Okay, and then we will plot. And you see, true and false can be abbreviated to just one letter. Okay. So now we have 3 hidden layers, 2 nodes in the input layer, and 2 nodes in the output layer. And once again, you can compare this against what we have in the textbook, and it will be the same. Okay. All right. So now let's see how to set up confusion matrix here. So let's say NN2 results, okay, NN2 net results. Okay. Now, if you look at NN2 results, it's coming in as a list. Okay. So since we have two nodes in the output layer, we have two values and they are coming in as a list. But handling list is not very easy or convenient. So what can we do? You convert this into a data frame. Okay, so convert that into a data frame, and so we have the two columns. But it has x1 and x2 as the names. Okay, so we have like first and dislike next here. So the output will be in that same order. So let's go ahead and names nn2 dot results. All right, like and dislike. All right, so now we have NN2 results as a data frame, okay, with like and dislike as the column names. Okay. Once we have that, then we can do the prediction. Okay, so these are what you have here are the link function, the output, what comes out of the node. So one way of doing the prediction is if this score is greater than this score, then we can predict it as like. Otherwise, we predict it as dislike. So whichever one is the larger value, that's the output that we will predict. So our NN2 dot predict pred, okay. So again, we can do an if else. Okay, NN2 results. Okay, so results like. Okay, if it is greater than NN2 results dislike. Okay, then our values will be like, right? Otherwise, dislike. Okay. So now prediction will be like and dislike, and the actual value also will be like and dislike. So they have to match, otherwise your confusion matrix will not work properly. Okay. Then we can do a confusion matrix. Okay. As factor NN2 dot pred. Okay. As factor tiny dot df acceptance. Okay, so I have a typo. Okay, so there you go. So that's again the difference between the one that we did first and now. In the first one, we had only one node in the output layer. Okay. Now here we defined two additional columns and used those two columns as the target. So now we have two nodes in the output layer, and we get the same